Okay, welcome back. Episode 9 underway. Today's episode is Size Matters. Unless you're inspecting a house, size does not matter. So I want to get into this a bit. A lot of times I get phone calls for inspections and the person on the other end is like, hey, can you squeeze us in at this time to do this little tiny house? No, I can't. So sorry. It's a house. It's a detached single family home, which means it comes with the same equipment that most other houses have. So they all have to be looked at. When they call, it's kind of like they think you're just going to rush through it because it's small. No, that's not how this works, everybody. So if you're buying a small house, when I say small house, I'm talking something barely 1,000 square feet. But understand, a house is a house. It's going to have bathrooms, it's going to have a kitchen, it's going to have a laundry, it's going to have electrical, plumbing, roofing, heating and cooling. Well, not always cooling, but heating at least. And probably a garage. So, there's quite a bit to look at, and it's the same process as any other house would be. So it doesn't really matter on the size. But what I want to point out is, oftentimes when I do these small houses, they have far more problems or system defects than, let's say, a 5,000 square foot house would have. And 5,000 square foot houses have multiple systems, like multiple heating and cooling, multiple electrical panels, and so forth, and probably 4 to 5 bathrooms. And these little houses can definitely outweigh them when it comes to issues. So what I want to go over is a recent home I did that was barely 1,000 square feet. And that's why I thought it would be interesting for everyone to hear this. That's why we're doing this on the podcast today. So remember, if you're buying a home, don't panic. Just check out the rest of this podcast. So let's see. Let's start with the worst first. So remember, this house is barely 1,000 square feet. It was built in like the early 1950s. And it's got a raised foundation. So what could possibly go wrong, right? Well, let me explain that. So the first thing I want to get into is the heating system of this house. So I'm inside the house. I see the thermostat. I turn it on just to get the heater going. And by the way, this is a very simple gravity wall heater. If you're not sure what that is, it's a heating system that's built into the wall, and the grill sticks on the wall to cover the unit. And these are typically found in early 1950s homes. Not a problem. And so I put the thermostat on and nothing happens. I already know the gas to the house is on because I've already been outside and looked. And so I just checked the inspection cover at the bottom of this grill here, and the unit is turned off. And that's a good thing, because I'm going to get into why that's a good thing. So this unit is not in service. So then I go up in the attic, and then when I get in the attic, I notice right away that the exhaust vent pipe is disconnected. Completely disconnected. Not just like a little bit, not just like a open seam at one side of the pipe. It's literally been moved over and left there, which is mind-boggling to me. So this pipe is what looks like a transite pipe, and transite pipe is known to contain asbestos. So it kind of makes you wonder, well, when they upgraded the wall gravity furnace, why didn't they just run new metal pipe all the way up through the roof? I don't understand some people's logic, but typically it all comes down to spending money and doing it the cheapest way possible. All right, so let's get back to the fact that this thing is not in service, and it is completely disconnected in the attic, about 5 or 6 inches before the wood roof framing. And the second thing I notice is that the wood roof framing is black, which tells me that this has been disconnected like this for quite some time. So the owner of this house is lucky it did not already catch fire. Seriously, there's a lot of charcoaled wood right above this exhaust. So this is a fire hazard waiting to happen. So this is a major safety issue, and I point this out very in a very high alert fashion by using red banners and red arrows to let my client know, do not use this furnace until this has been fixed completely. So let's move on. And let's see, what else did I find here? The electrical system. All right, let's have some fun with electrical. So on the outside of the house, I found a Federal Pacific Electric panel, which is otherwise known as a stab lock. And these are known to have electrical issues and be safety hazards. These panels are known to catch fire. These breakers are known to fall off just by removing the inner cover. And so any home inspector, anybody in the home inspection business knows this at this point. If you're a new inspector, you may not. You may not have come across this yet. However, that's what we're here for. Let's just educate everybody and share some knowledge. So this panel should be upgraded. It should be replaced. And right next to this particular panel was a Zinsco panel, which looks like it was the original panel to the house. So somebody took a Zinsco brand, which is not much better than this Federal Pacific, and upgraded to the Federal Pacific at one point. But back when they upgraded this, they didn't know these were bad panels. So you can't blame the person who upgraded it because nobody knew back then. It wasn't for some years later when they started noticing failures and fires and everything else with these panels. So, when you're inspecting a house and you see this, it raises a red flag for the inspector. So now, right away, what's inherent with this type of panel is poor grounding. These panels were never typically grounded properly, which means the receptacles inside the house, in most cases, are not grounded either. So, as I continue my inspection and I start checking wall receptacles, lo and behold, they're all open grounded or ungrounded or just plain no grounding. So, so the majority of the house, all the receptacles gave me the same reading on my tester. So that's a problem. You got these two old panels outside. You got ungrounded receptacles inside. You got GFCI receptacles on the outside that also had problems. And then when I get into the wiring into the attic, I noticed missing junction boxes, spliced wires, which should be spliced together inside a junction box. And then I found some open junction boxes as well. And then under the house, I found old conduit for the electrical wiring that was just lying on the soil. It's all rusted. So there's just a lot of electrical issues here on this tiny 1,000 square foot house. So the next thing is for a electrical contractor to come out here and further evaluate this whole electrical system and see what needs to be done. I'm quite confident any electrician would recommend upgrading these panels on the outside. And then one more thing I found here is I found an upgraded sub panel inside the house. Now remember, this is a 1,000 square foot house. And so far I see a main panel outside, which appears to be 100 amp. And by the way, that main panel, there's no labeling on the breakers. So I can't tell you what any of those breakers are going to except for the main, because that's the only one that's labeled. And then I go into the garage area, which is right near the laundry, and I see this upgraded sub panel. The first thing I noticed on the sub panel is there's no AFCI breakers. AFCI breakers are a pretty standard install as of 2014. And, the fact that that is not there is another red flag for me. So that kind of tells me that the sub panel was not installed with a permit, which it should have been, which also means that the person installing it may not be qualified to install it. So a lot of electrical issues to be concerned about here. And that is why I recommend they get an electrician out here right away. That's a lot of panels for such a small house. So that's definitely a head scratcher. Why did they go through all that trouble when they could have just upgraded the main and been done with it? So let's see, what else did I find wrong at this house? Okay, well, plumbing. Let's get into some plumbing. Plumbing was quite interesting, to say the least. So I remember when I was up on the roof, I only noticed 2 plumbing vents on the roof, which it's such a small house. Is that a problem or not? Not sure yet. Got to finish my inspection to determine all that. So the house turns out it has 2 bathrooms that are back to back. So they're sharing the same main vent, the 4-inch vent. Most likely that's okay. And then there's the kitchen. So the kitchen may be running off the second pipe I saw on the roof, second vent pipe. But what about the laundry area that's on the other side of the house? There is absolutely no vent there. So now we get plumbing vent problems, which means plumbing drainage problems, most likely. Or I may have some plumbing odors inside the house. Let's check it out. So continuing on with my plumbing, I notice on the main water shutoff, there's no bypass relief valve there. So I definitely recommend installing that after the regulator. That's there for the purpose of if a surge of water from the city comes into the house line, it's not going to damage pipes, damage faucets and fixtures and so forth. And it allows the relief valve to open and relieve some of that pressure if it's just too much. And water pressure regulator was definitely a little bit high, so I also recommend getting that looked at. So when going into the house and looking at the plumbing under the house, I noticed a lot of issues there. And one of the issues is a lot of the drain pipe that was visible under the house was upgraded to ABS plastic, which is a good thing. But if it's installed wrong, it's not a good thing. And in this case, I saw a lot of poorly pitched, sloped, inadequate slope drain pipe, which means it's going to hold water and it's not going to drain as it's supposed to. So we've already got plumbing issues vent-wise because we're missing a plumbing vent on the roof for the laundry area. And now double that up with inadequate slope on pipes, and you're going to have a recipe for poor drainage. House is not going to drain right, and you may get plumbing odors back into the house because of this. And then I also noticed non-standard materials such as rubber connectors on horizontal pipes. Rubber connectors on horizontal pipes should have a metal sleeve around them to keep the pipes from sagging on either side. Just a rubber vent is typically okay on a vertical pipe. And then in the kitchen, I find an S-trap under the sink. An S-trap is going to have siphoning issues, and it's going to cause drainage issues. So that needs to be fixed. Not to mention when I did run the water in the kitchen sink, the right side sink was backing up as I was testing it. So I'm sure that has something to do with the S-trap. That was the closest plumbing issue right to the sink. And then getting into the gas piping, I did notice some corrugated stainless steel tubing, which the manufacturer recommends be bonded on each end. And it was not bonded in this application that I saw. As far as the water supply pipe goes, I did see copper pipe, which is a good thing. However, the copper pipe I could read was type M copper, which is the thinner of the two. Type L is highly recommended, but type M is a cheaper version. So the inherent problems with that is it pits quick and it can start leaking faster than type L. So that's definitely something you want to change out and upgrade to a type L copper. Let's see, what else here? All this I'm mentioning, by the way, is in a tiny 1,000 square foot house. So let's get into the foundation area, crawl space. First thing I notice entering the crawl space is a large amount of debris that is just filled the crawl space floor in this property. This tiny little house is completely filled with wood, drywall, plastic, pieces of old pipe, pieces of the newer pipe that had just been cut off and left there. There is just a ton of debris under this little house. I couldn't believe how much debris was under there. And that's dangerous for anybody entering. And that's one reason why you don't want it left there. Second reason is a lot of that debris is wood. And wood in contact with the soil is a great way to have termite issues, subterranean termite issues coming because termites are in the ground, and if they sense wood above it, they'll get right to it and they'll start building trails, and who knows what else they'll do, and they'll start eating up your house. So the amount of wood I saw under this house was just ridiculous. It's everywhere. So yeah, that needs to be addressed and removed, all of that. Just got to send somebody under there with a bucket. Just fill up those buckets and then just take them out one by one until you get all that out of there. It's the only thing you can do, unless you invent some kind of a, rake system or something. But yeah, that needs to be taken care of. And so, as I mentioned, most of the soil floor was covered with debris. Some sections were not covered. And that exposed expansive soil. So if you've listened to my other podcasts, you may understand what expansive soil is, because I have gone into detail on that in some of the other episodes. But if you haven't, I'll just cover it right now for you. Expansive soil means the soil has a lot of clay in it. And when it gets wet, it expands. And when it dries, it shrinks. So this whole process of expanding and shrinking has the ability to move your foundation up or down, side to side. And it can also move your posts and piers that are also part of your floor framing system. So all of these implications from the expansive soil can result in drywall cracks, foundation cracks around the house. It can cause floor deflection, and that's a big reason why you see a lot of drywall cracks in ceilings and walls inside houses that have expansive soil. It's gonna continue to happen if you allow moisture to keep getting underneath your foundation. So, to stop the bleeding here, so to speak, it's important to have rain gutters on this house that's on expansive soil, and install some area drains around the house that you can connect the gutter downspouts to remove as much water as possible from the foundation perimeter, to keep moisture from getting under this house and allowing that expansive soil to move by being wet and then drying. So these things can be addressed. It won't stop the problem completely, but it'll stop the bleeding and definitely improve the condition and hopefully minimize future foundation cracks or, wall cracks, ceiling cracks, and so forth. But this particular house had quite a few foundation cracks. I counted at least 7 in this 1,000 square foot house. That's a lot. That's a lot of cracks. 2 of them were about 1/4 inch or bigger, so those need to be addressed. The other ones were mostly typical cracks. So not a severe amount of damage anywhere from all the movement in the expansive soil. So this house has expansive soil to deal with, and we're on earthquake land. So, you can have an earthquake cause a crack. You can have expansive soil cause a crack. So it's part of living in Southern California. Sorry, everybody, but that's just the way it is. And that about covers that on the underside of the house here. And covered the plumbing problems. So this house has a good amount of issues. So in total, what I've done here is I have called out 40 recommendations on this house, 12 of which are system defects or safety hazards. So the size doesn't matter. It's been my experience that most of these small homes have a lot of problems, a lot of issues. When I say issues and problems, what I mean is, deferred maintenance, inadequate installation of a system, whether it's plumbing, electrical, heating and cooling, roofing. The only thing this house had going for it was the roof was in good shape. Everything else, all the other major systems needed some significant upgrades or repairs. So that's what this episode was all about. The size doesn't matter. And hope you found this helpful and informative. So the good news is I am recording this episode of this podcast, and there will be a YouTube version of this where I will put images of these system defects I mentioned so you can get a better understanding of what I'm talking about. And I'll put that link into the podcast description as well once the video is done, which may be a few weeks. So anyway, that's it for episode 9. If you got any questions about this, any comments, I'd love to hear them. Just leave some comments. If you want to leave a review on the podcast, I appreciate that as well. And let me know if there's something you want me to cover. If there's something specific, electrical, plumbing, heating, foundation, whatever it is, roofing, anything like that, let me know and I'll try to get an episode for you there. And that's it for now. So signing off. Episode 9 is complete. And thanks for listening.